Today we'll be doing a tutorial on provisioning Kasm Linux and Windows workspaces using the new Kasm OpenStack Autoscale provider. In this demo, we'll be using OpenMetal. OpenMetal provides hosted OpenStack private clouds in seconds and has been validated with the Kasm OpenStack provider. More information can be found on openmetal.io. We've already created an OpenStack deployment leveraging OpenMetal. Here you can see the console. This deployment has been set up using valid certificates, as Kasm requires that the OpenStack endpoints present valid certificates. Here you can see that Chrome trusts this connection. I have already created an instance for the Kasm deployment. It's a Gen Medium for vCPUs and 4 gigabytes. You can take a look at the Kasm documentation sizing guide for some insight on sizing. This should be a good place to start for a demo. It's running Ubuntu Jammy, and it is publicly accessible using this IP address. A DNS record has been set up to point to this Kasm deployment. I just navigated to the URL here. Here's the admin console here. We're going to go ahead and start by configuring the zones. In order to set the upstream auth address here, this is used by the Kasm agent to check in. I'm going to set it to the URL we're using to hit this deployment. I'm going to save here. And then we'll go into pools. We'll create a new auto-scaling pool. This one will be for Kasm agents. Just call it OpenStack, get more clear. All right, this is the pool that the agents will be placed into once they're provisioned. We need to create an autoscale configuration for it to configure the autoscaling. So we'll call it OpenStack agent autoscale. We'll want it enabled. There's more details about these settings in the Kasm docs. I'll just enable aggressive scaling. One standby core for this deployment. The standby cores represent the number of cores that the Kasm autoscaler will attempt to keep on standby for new workspaces. No standby GPUs, no standby memory. I like to put 60 seconds for this downscale back off. For this agent cores override, we're going to want it to match what the flavor that we're using to provision. In this instance, I'm probably going to use a Gen Large, which is 4 CPUs and 8 gigs of RAM. So I'm going to just do 4 CPUs, no GPUs, 8 gigabytes of RAM. Next, we have the Nginx certs here. These are only really important for deployments that use the direct-to-agent workflow, as these are the certificates that are presented by the agent when making connection. Since we'll be using a workflow that involves proxying from the API server to these agents that are being newly provisioned, the certificate doesn't really matter too much. In this instance, I usually copy the SSL certificates and keys from the deployment's API server. So here I'm SSH'd in to an example server. I will go to op kasm current cert and copy kasm nginx.cert. These are just self-signed certificates. They're not sensitive. Copy this one here and copy the nginx key. Need it here. And here, they're both copied in the cert into the cert field and the key into the key field here. The next thing we're going to do is create an OpenStack provider config. We're going to select OpenStack. The name, we can just call it OpenStack agent config. The instances, this is the upper limit of what Kasm will allow to be provisioned. Certain OpenStack deployments might have an upper limit for the number of instances allowed, so you could set it to that. In this instance, we'll just set it to 10. The identity endpoint comes from the OpenStack deployment. Out of this, and we can go to API access here, and we'll look for the identity endpoint here. These all need to present valid certificates. So in this instance, you can see that Chrome trusts it. Connection is secure, and it needs to be the case for all the identity, compute, volume, and image endpoints. So copy this in. The next thing we want is the Nova endpoint. You can grab it from the compute line here. Paste this in. The version, so 2.90 is a safe value, but the latest version can also be found by pasting the endpoint URL into your browser's address bar and taking a look at the version field. So let's put this in here. The glance endpoint is the image endpoint here. Put that in. Version 2, and the sender endpoint, that's volume 3. Version 3 in this case. The project name, it's the name of the project you want to provision those resources in. So here we have admin. Just go ahead and put admin. Now there's two authentication methods that Kasm supports. There's the normal user one. And when using this method, the project domain name and user domain name can be found by going into the OpenStack UI, going to the API console, and downloading the OpenStack RC file. The fields can be found by inspecting that RC file. In this case, we're actually going to use the application credentials, since they are designed for these kinds of applications and allow for additional permissions restrictions. They can be set up by going into OpenStack UI and going to Identity and Application Credentials. We're going to create a new one. We're going to create a new one here. Call it Kasm Autoscale. Going to have the admin role. And for these access rules, we can restrict the application credential to the minimum set of permissions needed for the Kasm Autoscaler to function. The rules I am copying are from the OpenStack Pools page from the Kasm documentation and can be found at kasmweb.com. And then we're going to create the application credential. I want to just copy the ID here and the secret. Now the metadata, these are extra tags that can be applied to the images. If you want to tag your resources, and in this instance, we're just going to leave it blank. So open and close curly brace here. The image ID, let's get out of this credential dialog here. This is the image you want to use to provision this instance, the agent. We're going to use Ubuntu 2204 here. I'll just grab the ID, put it in, the flavor that we want to use. Compute. I generally like to just grab it through here. There's other ways to do it. In this case, we want to match the CPU and RAM override. So we have 4 CPUs and 8 gigs of RAM, so we'll use gen large here. And then create volume. So if we leave this unchecked, it's going to use the disk size here, the root disk, and create an ephemeral disk using the Nova service. Some providers have a restriction on the size of the ephemeral disks. They might not allow you to use it. And we like the flexibility of being able to adjust the disk size. So we'll go ahead and create a volume. We can set it to 100. The volume type, again, this might depend on your provider. Some have a certain kind you might want to use. In this instance, we're just going to use the default one. So it's Dunder default. And then the startup script. So the way we can find this is by searching for Kasm startup scripts, Google, and we have a GitHub repo here. These contain all the startup scripts that can be used with Kasm. In this instance, we're going to use latest, but it needs to match the version of Kasm you're deploying. Since I'm using a developer preview build, I'll use latest. But you might have 1.15. So I'll select latest. We're installing a Docker agent. And grab Ubuntu here. And we'll just go ahead and copy and paste this in. Go. What this script does is it downloads and installs the Kasm agent. Part of the script is it needs to know what its IP is so the Kasm API can reach back. We're going to go ahead and comment out this AWS internal IP. And since we're using a public IP address, we're going to uncomment this one so it knows what IP to use. And got it all in here. The next thing is the security groups for Kasm. These are the security groups that are applied to the agent that gets deployed. So we will go into network. Oops. Security groups here. And in this case, we want to allow HTTPS inbound and SSH just so we can log in and troubleshoot. So you can actually use the IDs or the name here. I'll use the names for easier readability. This is a JSON list, so we're going to have HTTPS ingress and SSH for troubleshooting in case there's an issue that pops up or we want to access the agent. Finish that up. Next thing is the network that this agent is going to deploy to. In this case, I'm using my external network. So we'll go ahead and copy the ID in. The next thing is the key, the SSH key that gets used. Go back into compute here. Go ahead and use the EM key. Availability zone. The default one is Nova, but it might depend on your deployment. And this is an advanced option to override certain configs. We'll go ahead and just leave that blank and finish. After creating our new provider config, after a few moments, we should see in our pool here in the Docker agents, an agent should be created. If for whatever reason one doesn't pop up, a good place to check would be the logs here and take a look for any errors. If you don't see any, another method to look might be to log into your Kasm deployment via SSH and take a look at this manager API server.log. It's an opt Kasm current log. And we'll just go ahead and look at manager server.log. Now, if there were an issue, you might see an error in here. In this instance, we see that it's created a server. So if we go back into our deployment, we should see an agent in the starting status. What the starting status means is that the agent has been created in the provider. So if we were to go into instances here, we'd see a new agent being provisioned. It actually matches the ID here, 478 and 478 here. Now the starting state means that it has been created in the provider. It only shows running when it's checked in. So it needs to make a call to this API server to check in. If you were to see an agent stuck in starting for like a few minutes, or perhaps you'd see one starting and eventually would time out, it'd be deleted and you'd see a new one starting. That would mean that it's either having an issue installing the Kasm service or checking in. If that were to happen, the first thing I like to check is just like a quick sanity check on the zone configuration. Go here and make sure this upstream auth address matches this. If it doesn't, it would be checking into the wrong IP address, so we just want to make sure they match. The other thing to check would be the logs. So the usual way I do that is I grab the IP address here, and then I go ahead and SSH in. And the startup script that we use uses Cloud Init. So on Ubuntu, the Cloud Init logs can be found in var log Cloud Init output. Go ahead and skip to the back. In this case, it's working fine. We can see that the Kasm agent has installed. But you might see an error in here. It'll complain about something. This is a good place to check. Another, if this were to finish successfully and you still don't see it checking in, you can check the logs for the agent. So here I just ran a Docker PS to list all the services. And the logs we're interested in are the Docker agent logs. So, or the Kasm agent container logs. So just pull these here. And you might see an error in here. In this case, it's all healthy and happy. You can see it's sending a heartbeat to the correct address, and it successfully did it. So everything here seems to be working fine. I'll just go ahead and go back into Chrome. Take a look at this agent again. Now we can see that it's running. So what the agent is going to do after it checks in is it's also going to try to pull down all the images that you have configured. So far I just have the jammy image. So I'm going to go ahead and launch the session. If you were to get like a pop-up when you launch the session that says no resources available, that could mean that the agent is still pulling down that Docker image. They're a few gigabytes, so it's possible it can take a few minutes, especially if you have a lot of images. But this one was pretty quick. So here's our Kasm session. Now this is all running in OpenStack. Another thing we're going to take a look at is creating a Windows Kasm workspace. So we'll just kind of start from the beginning here. The first thing you're going to need to do is upload a Windows image to the OpenStack deployment. Your OpenStack provider could possibly already have a Windows image. In this case, with OpenMetal, we needed to create a Windows image using their guide. They have a guide here, building Windows Cloud images on OpenMetal. I followed this to create the Windows image, and then I uploaded it to my deployment here. So we have a Windows 10 deployment, or Windows 10 image here. And we're going to use that for our workspace. So I'm going to go ahead and create a new pool here. We'll name it Windows Workspace. Yeah, Windows servers. The server type. All right, next we're going to go ahead and create a pool for these new Windows workspaces. I'm going to call it Windows 10. to match the kind of images. Server type. Create a new Autoscale configuration. We'll go ahead and call it OpenStack Windows 10. I want it enabled. We can turn on aggressive scaling. Default zone. We're going to use a Windows agent in this example. If you didn't, we're using a domain controller or didn't want to rely on the Kasm Windows agent, you'd leave this unchecked and would not use that method. But in our case, we will. Going to use the RDP connection type. And then the port needs to be, 3389. So in this example, we're going to use the dynamic Windows accounts, where the Kasm Windows service creates the user. So for the username, we're going to call it SSO_create user. This is like a special value where it's telling the Kasm Windows service to create that user. The connection password, we can leave blank or really put anything in it. When we use SSO_create user, the password is ignored. Connection info, we can leave blank. We're not creating an Active Directory computer record. The reusable option determines whether or not a new user can connect to an existing server after a session is completed. Otherwise, all sessions will need to land on a fresh new server. In this example, we'll leave it unchecked. The minimum available sessions are the number of standby sessions Kasm always attempts to maintain. Since we are only using this pool for testing, we're going to set it to 1. This could be increased if you expect a large number of users to create new sessions within a given time period. Next, we're going to create a OpenStack Windows config. So provider config here. So we'll just call it OpenStack Windows 10. Max instances, we'll do 10 again. And then we need to put in our endpoints again. So just copy identity. Sender endpoint version. And next, we're going to make the new OpenStack Windows provider config. I'm going to name it OpenStack Windows 10. Set the max instances to 10, and then put in our domain information here. This field, can I copy over identity? Nova endpoint, Nova version, glance endpoint, the glance version. I have a new set of application credentials here, but you could use an existing one. The metadata, we can just leave blank for now. And then the image ID will be the Windows image you uploaded. Go ahead and go to compute images. I have the Windows 10 image. The flavor, I'm just going to use Gen Medium in this case, so it's, I believe, 2 cores and 4 gigs of RAM. I'm going to make a new volume here. Going to make it, we can call it 150 gig. It's the default volume type. And then the startup script again, we can find it in the some Autoscale scripts, our GitHub project here. Needs to match the version of Kasm we're using. In this case, it's developer preview, so I'm using latest. And we're installing the Windows service since we're using the account creation, and the AWS scripts work for OpenStack. Just copy it in here. Security groups. The important thing here is these Windows servers need to allow RDP and port 4902 from the API server to connect in. They also need to reach the API server on port 443. So I have a, this is not right for security groups. I have a Kasm Windows security group here. And you can see it allows port 3389 from the Kasm API security group and port 4902. We obviously need RDP for the remote desktop connection, and then this is the port that the Kasm Windows service uses. And there are calls that are done from the API server to the Windows service that need to be able to reach it. So I will just copy this security group ID and paste it in here. And we will also grab our network ID from here. Nova availability zone, and there's no config override for this. All right. So in a few moments, we should see a new instance pop up here. You can see our existing gem and existing Ubuntu agent is still running. Let's take a look at our logs. And in just a few moments, we should see a Windows server pop up. Gonna have a peek at the manager logs just to see what it looks like now. This is the manager API server log from earlier. So we can see it created an instance and created the volume. So we should now see it in OpenStack. Just a second. Let's take a look. The instances. And there we go, it's running. So it needs to do something similar to the agent. It needs to kind of boot up Windows. We use cloud-based init to set up the server, and then we have our own user data that installs the Kasm service and has the Kasm service check-in. While we're waiting, we can just take a look at the log. It'll take a while to boot in some cases. But I like to sometimes just refresh this to see what's going on. After a little bit more waiting, we can see that these console logs are now starting to show up as cloud-based init is running. We can check back into our pool. See how the server's doing. It's still starting. All right, and just a little bit longer, you can see that cloud-based init is done, the service is stopped. and take a look at our Kasm Workspace or Kasm servers in the pool, and we can see that the server that's provisioned is now running. In terms of troubleshooting issues that may go wrong, a good place to look is this log here. If the instance fails to come up, you may see errors in that manager log or in the action log here. Sometimes logs will show up in OpenMetal. If the service is unable to check in, another thing to do is just try to log in using a local account that was used to create the image. Now that the server is running, there's one extra task to do to ensure that these are provided to users. We need to create a workspace for this pool. So we'll go ahead and go to add a workspace, create a pool workspace, and we can call it Windows 10. Windows 10, enable it, and then from the pool, we'll select our Windows 10 pool. And then save this. Click back here. You can see it shows up now since we created the workspace. And we're going to go ahead and connect. It's creating a session on the server, and it's connected. So now Windows will log in using those temporary local accounts that were created by the Windows service. Now we're logging in. It's going to use one of the dynamic local accounts that were created by the Kasm agent. Since the username field has SSO create user from earlier. And this is going to take a little bit of time to log in. And while we're waiting, I'm just going to go ahead and show off that since we're now in a session and we're consuming a session, like a user is using one session, and our pool we have in the Autoscale config, since we have the standby server set to 1, it's always going to try to maintain that minimum 1 available session. So it's actually, right now it's creating a new server just to fulfill that requirement. All right, here we go. We're in our session. And here's a Windows session. It's running on OpenStack. It's dynamically provisioned in your private cloud. We can upload a file if we want. We can do anything that we'd be able to do in a normal Kasm workspace. Next file I just uploaded. Can use Microsoft Edge. And when we're done, we just delete it. Thank you for watching this tutorial on configuring the Kasm OpenStack Provider for Docker and Windows agents. For more information on Kasm Workspaces and for more technical configuration options, please visit our website at kasmweb.com and navigate to our documentation. An OpenMetal private cloud was used throughout this video tutorial. For more information on OpenMetal, please visit the OpenMetal website at openmetal.io.